Hello everyone. In this video, we will talk about homework 4's problem 1. So, you know that the y is defined as gx when like this way. So, when x less than 0, it equals to 1. And when x in 0 to 1, it is 0. And x in 1, 2, it is negative x minus 1. And when x larger than 2, it is negative 1. So now we can receive a relation, a plot of y equals to gx and x as this way. So less than 0 here, in 0 and 1 here, and in 1, 2 here, and then others. So from this plot, we can see that y is in the range of negative 1 to 1, and therefore we can receive the CDF of fy is equals to 0 when y less less than negative 1 and 1 when y larger than 1. That is a basic property of the CDF. So then we discuss what will happen when y in negative 1 and 1. So as the plot we have, when y equals to negative 1, and then the p y equals to negative 1 is equals to the part, let's see the part. Here we can receive the property of p as well, which is the property of when x larger than 2. And this one can be considered as 1 minus x less than or equals to 2, which is 1 minus x2. The boundary part 1 is developed. Then also 0 is also need to be talked, since there has been divided into two conditions, and x and yx equals to 0 only, y equals to 0 is only taken by when x is equals to 0 here. So here has the equality and here not. So part of 0 needs to be talked. So when y equals to 0, the probability of y equals to 0 is equals to this part. So it is when x is in the range of 0 to 1, and it is equals to fx of 0, f of y minus fx equals 0. So, and also the inner boundary of this condition of talk about y is when y equals to 0. So here we have y equals to 1, and we can see that this part is equals to is when y equals to 1, and here is p is less when the x is less than 0. So which is fx of 0. Then in the range of when we didn't have anything between 0 and 1, so we don't need to talk about more. But in -1 to 0, here is also a slope, a linear equation here. So when y is in -1 to 0, y(x) equals to -x plus 1. And from this plot, we can have fy, the PDF of y is equals to, here is the fx divided by the differential of gx. It is and here is the gx y in -1 to 0, and so we take its derivative as the -1, the observable value of -1, and here we replace the x by y, which is x equals to 1 minus 1, the inverse function. So it's like this way. This one is 1, so just so the fy, the PDF of fy is equals to the PDF of 1 minus y on x. So as a summary, we will have fy of y is equals to 1 minus fx2 when y is on -1. So we also have an impulse on -1 this way. And fx is when y in -1 to 0, and fx1 minus fx0, and here also have an impulse, so on 0, so we have here y equals to 0, and also fx0 times, here also have a change, so give an impulse on y equals to 1 and 0 for otherwise. And it plots as -1, 1, and 0. Here has different kinds of impulse, and also a connection which impulse the linear. So it's fx 1 minus 1 here, this way. For to talk about fy, since as we talked about before, the out of boundary of y over -1, 1 is 0 and 1. So the middle of here, we talk about y in -1 to 0. So in this time, fy is equals to p when y less than the given y. It also can be replaced by the linear function as the 1 minus x less than the y, and which is So here can be transferred as the probability of 1 minus the probability of y of x when it's less than and equals to y, which is of x of 1 minus 1. And since and when y in 0 and 1, so since only the gx can be larger than 0, the y equals to gx will be less than 0. So and all this time where x is larger than 0, and so that when y in 0 to 1, we only take the higher boundary of it, which replace the y minus 1 equal as the 1 equals to fx0. So write in general as fy of y equals to 0 and 1 minus fx equals to 1 minus 1. Here is for x less than -1, and here is for when y is y in -1 to 0, and also 1 minus fx0 when y in 0 to 1, and 1 for y larger than equals to 1. Also plot it as when -1 to 1. Here we have the function from 1 to 1, as this one is 1 minus fx of 1 minus 1. And after that will be 1 minus fx 0. And here has the density, the gap, which is size of fx0, and here finally reach to 1. Otherwise it's 0. This problem is done.